Let's have a look at question 2. A particle moves in a straight line and its displacement from a fixed point is given as that. So it's modeling, that function models it, where t is measured in seconds and s is in meters. A, find its average velocity in the first 3 seconds. So we're just going to use this equation here. We're going to put in 3, we'll then put in 0, and we'll do our y2 minus y1 on x2 minus x1, find the gradient. Let's do that. So the first one we'll do will be 3 equals minus 3 cubed plus 2 times 3 squared plus 4 times 3 minus 2. That is minus 27 plus 18 plus 12 minus 2. So minus 27, we've got 18 and 12 is 30, minus 2 is 28, so that'll be 1. All right, now we're going to do the same and find it for 0. Well, it's pretty easy. It's going to be, well, that'll cancel. That term be 0, 0, 0, and this minus 2 equals minus 2. And remember, the average velocity equals, it's going to be our S3 minus S0 over 3 minus 0. S3 is 1, S0 is minus 2. We'll put that over 3. 3 over 3 equals 1 meter per second. Okay, in part B, we have to find its velocity and acceleration at t equals 3. So to find the velocity, we take the derivative of this function, and that gives us the velocity function. And to find the acceleration, we take the second derivative of this function or the derivative of the velocity function. So let's do that, and then we'll put in t as 3 at the same time. So we'll do the first one will be the velocity function, which will look like this. So it's minus 3t squared plus 4t plus 4. And what we need to put in there is 3. So we've got minus 3 times 3 squared plus 4 times 3 plus 4. So that's going to be minus 27 plus 12 plus 4. That's going to be minus 11. Now the second derivative, remember, I've got to take the derivative now of this one, or I could take, well, it's basically the second derivative of that. So that's the first derivative, I'm going to take the second derivative. Let's do that. Okay, so that's going to be minus 6t plus 4. And for the second derivative, we're also interested in the point of t equals 3. So it's minus 6 times 3 plus 4. Well, that's minus 18 plus 4. That's minus 14. Okay. So what we have is we've got minus 11 over here. That is meters per second. And minus 14 is the acceleration. So it's meters per second per second. Now, C, determine if the speed of the particle is increasing or decreasing at t equals 3. Well, this shows it's a negative number, so the velocity is decreasing. But why don't we put it in the calculator? If you put it in your GDC and you plot this function here, our original function, that's the distance time function, you'll see that the slope is negative. Remember, the slope reflects the velocity. So it's not surprising that the derivative, which is the slope or the gradient, is also negative. So for those two reasons, and if you have a look at the graph, you have a look where t is 3, look at the gradient of this function, you'll see it's a negative gradient. And also, if you then want to plot the first derivative, which you can do on the GDC, you'll see that it is below the x-axis, or below y equals 0 in negative territory. So what does that indicate? It shows that it's decreasing. The velocity is decreasing there. Okay, number 4, find the value of t when the direction of the particle changes. Now this is going to happen where the derivative or the velocity changes from plus to minus, or minus to plus. In this case, plus to minus. Okay, so that would be the roots of this Let's look at that. So we have to find t when this equals 0. That will give us the roots where it's crossing the x-axis. All right, so we need to solve that. It looks like we can't factorize that, so let's just go straight to the quadratic formula. So we've got t equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That becomes minus 4 plus or minus, trust me here, 64 over minus 6. So we've got our two solutions. We've got t equals minus 4 plus 8 on minus 6, and also t equals minus 4 minus 8 on minus 6. This one becomes 4 on minus 6, which is minus 2 on 3, and this one becomes 2. Now we have to exclude this one because t is defined as greater than or equal to 0, and that's negative. So we're going to exclude that answer there, and we're going to look at this one, 2 seconds. So that's the answer for that. E, find the value of t at which the acceleration of the particle changes direction. Again, that's when it goes from plus, the acceleration is positive to negative, or negative to positive. Let's have a look at that. We're going to have a look at the second derivative for this. See, that reflects the acceleration. So we've already got that here. Minus 6t plus 4. Well, we're looking to solve that. Equate it to 0, minus 6t plus 4. Therefore, t equals 4 on 6, which equals 2 on 3 seconds. So at that point, at time of 2 on 3 seconds, the acceleration changes direction. Okay. Now, if you plot that on the chart, on the graph, you'll see that if you plot this function, just a straight line, you'll see that it crosses the x-axis at 2 on 3. Got a negative slope there. Okay. In its x y axis of 4. Okay, 2 on 3. Now, it comes over here. This is actually part 2 for E. Explain the geometrical significance of this point on the graph. Well, this point on the graph at t equals 2 on 3 seconds, the geometrical significance, well, we know that's a second derivative, and the second derivative when it's 0 is an inflection point. So that's what they're looking for here. It's an inflection point.